Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. And it's called Rat Run 31, Equivalence by Marty Sears and Justin Vitanza. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. F and P must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, share cells, cross themselves or each other, or pass through any thick maze walls. As well as moving orthogonally, they may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So the paths cannot visit any cell more than once. They can't share cells with each other. They cannot cross themselves or each other or pass through thick maze walls. What is the diagonal thing? The diagonal thing means you could go something like that. That is valid because there is no rounded wall spot between that. But for example, you could not do something like this because there is a rounded wall spot and you would be going through that, and that is not allowed in this puzzle. We have black courants, where if a black courant sits between two digits, one is double the other. We have red courants. If a red courant sits between two digits, one is odd and the other is even. So as an example, say this was a 2 here. This digit would have to be 1 or 4 to maintain the 1 to 2 ratio between them. And since this is even, this would have to be an odd digit, which would be 1, 3, 5, 7, 9. Because these two digits have to be different parities, which is another way of saying if one is odd, the other one has to be even, or if one is even, the other one has to be odd. We have teleports, where entering a yellow teleport will cause a rat to be instantly transported to the other yellow teleport, and the teleports have identical digits, so these digits are exactly the same. We have motion sensors, where a digit on the pink motion sensor indicates the number of cells that are visited by either rat within the up to 9 cells immediately surrounding the sensor, and the sensor itself is counted if visited. So, for example, if, say, one rat went through here and went here, and then the other rat, say, went through this way, it's not, I have to go this way. So we go this way through this path. Whoops. Let's just do this. Say this one rat went this way to get to the cupcake. This digit would have to be 9 because 9 cells in the 3x3 box surrounding it, centered on that cell, I should say, all have cells that are visited by rats, right? So this would be 9. This would be 6 in this case, and this would be, well, it would also have to be 6 in that case, which is interesting. So obviously that's not going to be necessarily working. Assuming this doesn't go anywhere else, this would have to be 2 in that instance because of the up to in the 3x3 area centered on the motion sensor. Only 2 of the cells are entered in by a rat. And that's an example of how motion sensors work. Finally, we have the test constraint. In this experiment, for any row or column the digits visited by f must have the same sum as the digits visited by p. Whoa. Okay, so in this experiment, for any row or column, so that means for each row and column, so the digits visited by f must have the same sum as the digits visited by p. And the sum must be determined for each row and column. So in row 1, the digits visited by f in row 1 must be sum up to the same sum as the digits visited by p in row 1. That is interesting. And it's the same for every row and column in the grid. Huh. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so obviously, P, we're going to make this one P, cannot just go straight to the cupcake. If she does, the problem is F is guaranteed to be in row 2. And the sum of the digits for F in row 2 is going to be at least 1, but then the sum of the digits in row for P would not be correct. So P is going to have to get to row 2. F is going to have to get to row 8 for these to work. Okay. And whoever gets to... So P is going to somehow have to get to row 2 and then go to a cupcake, which is likely this one would be my guess. F is going to have to get to at least row 8 and then get to the cupcake, which is probably going to be that one, be my guess. But that's not necessarily the case. This digit has to be 2 or 4 here because it's next to 2 unique digits, which it is in a 1 to 2 ratio with. So this is 1, 2, 4, or 8. This is 1, 2, 4, or 8. Okay, this can't be 1. If this were 1, the problem is only one of these cells would have a cell visited by a rat. But then this would be in the same situation, right? So the motion sensors on the edge of the grid must be 1 through 6 because they can be at most 6 cells with a 3 by 3 area that's centered on that cell. So if this were 1, this is at most 1 here, but then we'd have a duplicate here. So this cannot ever be 1. So if this is 2, this has to be 1, 2, and 4. This can never be 4 here, because if that were 4, that would force this to be 2, and then 1 to be in a 1 to 2 ratio. And that's not going to work for this cell here. Can this ever be 6? I guess so. Yeah, I could have 5 go here, and then that would be... So this cannot be 9. We don't know what that digit is. Any digit that's next to a black Kropke dot can only be 1, 2, 3, 4, 6, and 8, because 5, 7, and 9 cannot be next to black Kropke dots, because if they were, how would that work? Because you have take 5, 7, and 9, and you have them. That's not going... Okay, so this is guaranteed to have 1 here. But that doesn't tell us too much. Okay. Okay. F and P are somehow. F has to get to row 8 somehow. P has to get to row 2 somehow. We only have 2 entrances here. So if P goes this route, F has to go this route, but then we'll have to necessarily cross P's path. So that's not going to work. So P has to go this route, and F has to go this route, which means F does have to connect to this cupcake, and P must then connect to this cupcake. Since F has to go this way, so F is guaranteed to go this way route, has to go this way through. P has to go this way through. P, that's going to be interesting. P cannot go through that way, because that will necessarily block F from actually getting to here, which it needs to. So F will have to go through this way. That means P has to go around this way, but the problem with that... That's interesting. Oh, we have a teleporter. Never mind, we have a teleporter. Oh, okay. F cannot go this route, no matter what. If F goes this route, she will block P from... P will have to go out this way, but then F will be blocked from the cupcake here. Any of the cupcakes. So F cannot go this route. F definitely has to go this route or teleport. But if she teleports, the problem is, again, well, I guess P could come this way. The problem, well, she could go something funky like that. Okay, that's kind of problematic. Okay, one thing is P can never get to this area here. If P goes to row 1, well, I guess she could if she goes like that. She has to go from the teleporter. P cannot go through the non-teleporter and then... Basically, the teleporter is going to have to be used by one of the rats. We don't know which. Oh, these have to be 2 and 4 here. So 4 is guaranteed to be one of these digits here, which means this can't be 4. This then can't be 8. Because if this is 2, this has to be 1 and 4 there. If this is 4, obviously 4 is there. So that means 4 would have to be with 2 and 8 in a 1-to-2 ratio. That eliminates 4 and 2 in the rest of this column and the rest of this box. So this cannot be 2 or 4 here. Okay. So what are the possible combinations? F cannot just go straight here without using the teleporter, and then P not use the teleporter, because P would be blocked here from ever getting through this way. So P would have to go around here, but then F would never get to the row 1, and therefore they would not have the same sum in row 1. Same, so that means F or P must use the teleporter. Okay. If F were to use a teleporter this way, that's not going to work. P would have to get to row 1 somehow and still get to a cupcake. But that's no longer possible if F goes that way to the teleporter. Because then once P gets to row 1, there's no exit, right? She enters this way, she's blocked here. If she enters this way, she's blocked here. So you potentially could have something like that going to the teleporter. That is possible. How would that work? Okay, so if F uses the teleporter, that means she enters here. She must get to the cupcake. So that means she has to, I think we use green for that one. So she would have to do something like this. But then the problem is, so that means F cannot use a teleporter. Because she must reach the cupcake. She can't go this way and then enter here because P has to exit out somehow. So she would have to do something like this. But then that would necessarily block P from ever entering row 9. So then that would never be equal. So P necessarily must enter the teleporter. So P has to enter the teleporter and can go either this way or this way. We don't know which. Hmm. So P must enter the teleporter. F can then go... F cannot go this route. If she goes this route, she would block P from getting to the teleporter at all. So F has to does have to go this route. So she does have to go this way, which means this can never be 1. This can never be 1. Because both of these digits have to be... P has to enter in somehow this way to enter in to this cell. She could go that way, though, so that's fine. Actually, can she go this way? I don't think so, because she has to get to row 8. Because P is in row 8, F has to also go to row 8. If she goes this route, she can't get to the cupcake without either crossing P's path. So this is not in the path. This is not on the path. So P has to go... Sorry, F has to go this way. So this is at least 2 also. Actually, it has to exit out, so this is at least 3 also. Oh, that's interesting. This cannot be 6 because she doesn't enter this path, right? So if she tried to go this route, the problem is she has to get to row... Actually, I guess she could do that. 8. Never mind. That's not necessarily the case. So she could do something like that, and then P does... Oh, no, P is going to row 9. So, yeah, F necessarily also has to go to row 9, because P has to go through the teleporter. So, if you go this route, obviously you're not going to row 9 at all for F's path. So then, yes, that is correct. F cannot go that way. F has to go this way, which is at least 2 digits here, and it must exit out, so that's at least 3 digits there. Going that way. F is going to do something like that. P has to do something like here. Interesting, though. P has to go through the teleporter, go up to row 8. I guess it's possible. Go down, and then she has to go definitely to... Oh. That's interesting. So F is going to enter every row from 2 through 8. And 9, actually. P also has to enter every row from 2 through 9 then also. P has to goes at most through row 6 here. F is going to have to go in somewhere. Interesting. So P, so F has to go at minimum here. P also has to get to row 6, but cannot cross F's path. So she'll never be able to enter row 6 unless she goes this way. So that means necessarily P has to go this route. Because if P does not go this route, she's not going to be able to ever enter row 6 at all. Because F will block her by going this route. It also means, actually, P, to get to row 5, has to go this way. Because if she doesn't, she's never getting to row 5 at all, right? She'll be blocked. She'll stop at the cupcake. So P cannot go here. P has to go this route to get to row 5. So that means we have to do something like this. Actually, not here. We have to go from here to here to here. Could do something like that. That's potentially possible. We don't know where else she goes. So because of that, F has to go these routes, these digits there. P has to go along this path. Goes there, enters here. F has to get to here. And P, once P goes either this way or this way, she'll get to the cupcake. So she does not enter row 2. So she necessarily must enter row 2 here. She potentially could go all the way around. No, she cannot. If she goes all the way around, F will also have to go all the way around, but then these digits would have to sum up to the same as these digits, which is not possible because they add up to 45. These digits are never going to add up to the same sum because they have to be integers, and you can't have 22.5 on each side. So P can never actually enter. Oh, F has to get to row 1. P has to get to column 1 and column 9. So F can never, or P can never enter row 1, which means F can never enter row 1. F is going to have to get to column 1 because P does also. So she cannot go that route. She has to actually go through this. Could go this way. She has to go that way. Then to there. And she could go down and that way. That's possible. Okay. That's interesting. This has motion in 1, 2, 3, 4. Wait, that's only 4. That's not going to work. 1, 2, 3, 4. Dang it. Huh. That's a problem. Oh, it has to be 5 then. Okay, so she cannot go that way. She has to do that. That's interesting. So then this is 5. This cannot be 5 here. This cannot be 5. This then must be 6. So that means P has to go that route to get to the cupcake. So this must be 6 here. This is not 6, it's 3 or 4. That's interesting. No 6 here. Therefore, this can't be 3. These digits cannot have 2 or 4, so we have 1, 3, 7, 8, and 9. Yeah. Okay. This sees at least 3 digits, so we have 3 through potential. It can't be 9. These are never entered. So we have block, block, block. This is never entered. So this has 1, 2, 3, and could be 4, 5, 6, potentially. So it's 3 through 6 there. Interesting. These 2 digits. Again, P cannot do anything like this. So P, if P goes here, F has to go here, but then that's never adding up to the same sum. So P cannot go there. P can't enter this way either, so this is not going to be allowed. F can't enter here. F can't enter here. So it could be a singleton here. And in fact, we know F cannot go here, so F has to go this route. So F is going that way. So she doesn't enter here, which means this is never entered by anybody else. This actually doesn't have to go that way. She could do something funky like here to make these add up correctly. She does have to go that way, though. This has to come from one of these two. We don't know which. Okay, so let's color some of these then. These are guaranteed to be red. These are guaranteed to be green. We are guaranteed all of these are green. Interesting. These are all green. You can't, so these are not any, these are none, neither, right? These are red. We have red here. This is red. And this is red, obviously. Green has to go here somehow. And, okay, this is green. Has to get through here, so that's green. Has to go here eventually. Okay, so this is blocked. So none of these are ever going to be, this is never going to be touched. One of these two has to be. So this sees at least 2 cells. Cannot be 6 because this is never going to be touched. Any of these could be touched. Any of those could be touched. Any of these could be touched. Any of these could be touched. These are not being touched. You could have 4 digits and 2 digits here. We also have to do columns too to make sure that those add up also. That's kind of crazy. So none of these are being touched. Okay. Could have 2 there for green. This is definitely green. This is green. Okay, this is not being touched. She's not entering this way for P. So these could be green. These could be red. This is sensor. Again, has at least 1, 2, 3, 4. So this is at least 4. So this cannot be 1 here. Cannot be 6 here. Sensor here is 1, 2, 3, 4, 5, 6 at least. So this is at least 6 here. Could be 6 through 9, actually. Okay, so sensor, this is at least... sensor, okay, this cannot be. So it has to be 3 or 4 here. Interesting. Right, because it could be all 3 of these and then that. For the motion sensor, this has 1, 2, 3, 4, 5, 6. This has 1, 2, 3, 4, 5. This has 3 or 4. Wait, this is a motion sensor, right? This has 1, 2, 3, 4, 5, 6, 7, 8. So this is guaranteed to be 8. So we have 8 here, that's 4 here. This must be 2 to be in a 1 to 2 ratio, so this must be 3 to be odd. So this is not going to be reached by a rat, which means P has to go this route. So P must go that way. This is 3, so this cannot be 3, 6 as a pair. No 3s here because of 3 in the column. These can't be 8 anymore. This is guaranteed to be odd digit, 179. No 8 here either. So 179 here. That means this must be even. So we have 2, 4, 6, 8 as possibilities there because of the red courant. Okay, this is not going to be 1. It has to be at least 3. This is not connected. So this has to be 4 or 8 here, which means this can't be 1, which means we have a guaranteed 4 in one of these 2 digits. This cannot be 8. So this is a single digit. So this cannot be 4 digits here. So that means F cannot go this route. She has to go down here. And therefore, this is never going to be 8. She can't go straight down here because she has to match digits or match sums in column 1. So therefore, she must go this route. which means none of these has to be 4 because it can't be 8 anymore. That leaves us as 2 or 8. 4 eliminates 4 here, so this cannot be 8 here. That means none of these cells are visited because we already have all 4. So then green has to go there, green has to go there. So that's that path. 4, 5, 6, 2, 3, 4. So she definitely has to go through here. This is at least 5 cells. That's interesting. Oh, you cannot have the full 9 cells because we have the same problem that we did with row 1. You would have to divide 45 into 2 distinct sets trying to add up to the same sum when it's adding up to an odd sum. So that's not going to work. So she cannot go there. So the path does have to go this way. But she does not have to go directly here. She could go up here and then down here and then down here and here, or go diagonally here. Therefore, these must be the same sum. Therefore, since these are the same sum, these add up to an even sum, so this must be an odd digit. 1, 3, 5, 7, 9 there. Okay. Three digits here. That could add up to a singleton there. Or sorry, singleton there. Hmm. Yeah, it could be all 5. Hmm. F is obviously going to have to reach row 9 somehow. Okay. At least 4 digits and 1 digit there. This can't be 9 anymore because this is never being reached. So it's at 6 through 8. Hmm. Okay. This could be green. That could be green. Okay. We are guaranteed here. This is either 2, 1, 3, 6, or 2, 4 here. So this is either 2 or it's 3, 6 as a pair. This is either... Oh, it doesn't have to be 2. If this is 2 with something... I guess this could be 4, 8 still. That's not great. Huh. Okay. Um... Hmm. Okay. Um... We know these two digits have to equal the sum of these digits. That's at least 11. So this cannot ever be a 1 here. Can it be 3? If this is 3, this would be 4, 5, 6, and that's not going to be possible. Sorry, I'm getting some messages here. Anyways, shoot. Hmm. This cannot be 1, because if that were 1, the problem is that would be the sum of two unique digits to add up to it. So this is 7 and 9. We have now a 7, 9, 7, 9 pair in box 6, which eliminates 7, 9 in the rest of the box. This can't be 7 or 9, it's 1. This can't be 1, 7, or 9, it's 3. Oh, that's interesting. That means this cannot be 3, 6 as a pair, no 3, 6 as a pair, and no 1 here. So we're guaranteed one of these is a 4. So it's 4 with 2 or 8 in a 1 to 2 ratio. That means this can't be 4 here. Interesting. So 3 is going to have to be one of these 3 digits here. If we go down this way, this would then be 4. We'd have to have a 3 as one of these digits. 3, 4, 5, 6 adds up to 18, which 2 digits can never sum up to. So we cannot go down that path. It has to be these 4 adding up to these 2. She still could be 4 going here. That is possible. So we don't know where the 3 necessarily is. What's the minimum here? Potentially 1, 3, 5, and 6. Can this ever be 4? The answer is no. If this were 4, then this would have to be 3, 4, 5, 6, which adds up to 18. And 2 digits never add up to 18 if they are unique. So this cannot be 4 here, which means we have guaranteed 1, 2, or it's 3, 6 here. We don't know which. Minimum here is 1, 3, 5, and 6. That adds up to 15 at least. So this is 6 through 9 there. Cannot be 6. So it could be 7, 8 still. This can't be 3. If this is 3, that forces this to be 4. Again, that adds up to 18. So this has to be a 1, 2 pair, which eliminates 1 and 2 in the rest of the column. Interesting. Huh. Let's see what else we have. Oh, this is... Okay, we have 3 digits here, which is guaranteed 4 and 7 at least. That's 11. Green does have to go here. So then green has to go here to here to make sure that these add up correctly. We don't know what that is. These are at least 11. So we cannot have a 1 in these digits here. So it's 3, 5, 6, 7, 8, and 9 as possibilities. This cannot be a 7 or 9 here, because if this is 7 or 9 here, then this would add up to 24. Then this set would have to add up to 24, which means they add up to 48 in a row that can only add up to 45 at most. So this has to be 1 through 5, I think. Can't be 6, can't be 8, can't be 7 or 9. Yeah, so it's 1 through 5 there. Can we actually have 5? 5, 7, and 8. No. If we have 5, 8, and 9, that's again too large. That adds up. Well, no, that's actually not the case. 5, 8, and 9 add up to 22, which could work. Okay, never mind. So that's fine. You could have 3 and 9 here and 4, 7, 1. That is possible. This can't be 7 or 9 either. Actually, I don't even know what this can this ever be 8? So if this is 4, 7, 9, that's adding up to 20, which 2 digits can add up to. 4, 8, and 7 adds up to a minimum of 19, which 2 digits can't add up to. So this cannot be 7, 8, or 9. So this is 1 through 6, and a 2, 4. Can it be 6? 6, 4, and 7 add up to 17, which 8 and 9 could be here. So that is possible. Hmm. Okay, 4 cannot be here. 4 has to be one of these 3 digits here. Can this be 9? 45 minus 9 is 36. 36 divided by 2 would be 18. So it could be if it's 3, 7, 8. Seems fine. Don't have any information about this. Oh, these are the same digits, so not 3 or 4. 1, 2, 5 through 9. This adds up to 12. This is a single digit. Only one of these could be 1 at minimum. So we have to have one of these be 2, at least. 4. Okay, let's make sure the motion sensors are correct. This is 4. These are not visited. This is 3. 1, 2, 3. These are not visited. We have 6 here. We have 8 here. This is 5. This is 3 or 4. This is 4 or 6. This has to be 1, 2, 3, 4, 5, 6, 7, or 8. This at least has 3 exiting out, and it could be 4, 5, and that, yeah, the motion sensors are done. Essentially, we just have to fill in depending on what the path is. We need to calculate or calculate how to. Um. Hmm. Huh. Remaining digits in box 9 are 3 through 9. No 3s here. No 4, 3, 4, 8 here. No 5 or 6 here because of digits in the columns. Okay. So 1 out of 1 or 2 has to be here. Obviously, this can't be 3 anymore. Remaining digits of row 7 are 3 through 9. Okay. Oh, this is an even digit. This cannot be 4, 6, or 8, so this must be odd because of the red courant. Because this can no longer be 1 or 3 here. Hmm. This cannot be 7, 8, or 9. Because these two must at least must add up to this. Oh, this can't have more than 2. Oh, wait, no, this could be 8. This cannot, though, have 3 digits here because we don't have 2 or 3 available. If we have 3 digits, it would be 1, 4, and 5 at minimum, which does not add up to a single digit here. So these cannot be on the path. So it must be going this way. So F has to enter in once here and then exits back out. So then this must be 2 digits here because there's no, these 2 digits these can't be the same digit. So one of them must be the sum adding up to a singleton digit. Can this be 2 digits here? It would have to be 5 and 6 at minimum. 3, 5, and 6 already adds up to 14. So the answer is no. So she cannot go this path. So she has to go this way, which means this is a 3. So we have a 3 here. This cannot be 3 here. This has to be adding up to 4 and 8. So that's 3 and 9, which eliminates 9 in the rest of the region. No 9 here. These must add up to 9. So if this is 1, this is 8, 2, and 7, 5, 4, 6, 3, 2, 7, 2, and 8 and 1 are those. So this must not, this adds either 1, 6 adding up to 7 or 1, 8 adding up to 9. We're not certain. This is 3, 5. 3, 5, 6, which is 14, plus 1 is 15, plus 2 is 16. So this adds up to 16 or 15 or 16, which is 7, 8, or it's 7, 9. Either way, there is guaranteed to be a 7 here, which means this can't be 7. Okay. This adds up to 9. Can this ever be 8? That would force us to be a 2-4 pair. We'd have 9, 6, and 7 possible. I guess? Oh. This can never be 8. If this were 8, that means all of these cells would be visited. So red would have to be here, green would have to be here. And so, yeah, red would be here, green would be here. They would have to add up to the same sum, so that would add up to an even number, but the even number would have to add up to an odd with an odd digit to add up to 45, which is an odd sum. So this cannot be 8 here. It's 6 or 7. This is already 9. That doesn't help us much. Remaining digits in column 1. We have 1, 2 as possibility. 4, 8, and 9 as the others. Okay. If this is 6, these would be 7, 9 as possibilities. This would be 2 and 8. So we'd have 7, 9 here. 6. If this is 8 here, this has to be 2, and you could be 2, 4, 9, adding up to 15. So you'd have 8, 1, and 6 could work. These two digits can never be, so these two are the sum of this. So this is 3 through 9 there. This has to be 1 through 8 here. No 4 here, obviously, because 4 in the box. It's not helpful. Okay. I don't think we can go here. So, yeah, if we go here, that would be all green here. That's 5 greens. This would be 7. 1, 2, 3, 4, 5, 6, 7. So this would not be red. And we'd have 8, 9 here at most. 7 plus 1 plus 3 plus 5 is already 16, plus 2 at least is 18, which is too large. So we cannot enter that way. So we have to go that, oops, we have to go this path. This is not on the path then. Okay, so these 3 reds equal the same as these 2 greens. Okay. We can remove the black stuff. We don't really need that. Because we have the paths that we can go that are guaranteed, and we have the paths that we could go through. Can this be 6? If this is 6, I guess can this be 8? Two would be interesting. So 2, 1, 3, 5. That adds up to 11. So then it would have to be 4 and 7 here, with that being 6. Because we don't have any other possibilities there. So that's possible. Oh, these are 2 digits. So these two are 2 digits, which add up to at most 11. If we included this, the problem, actually, if we included any of these, the problem with that, okay, so this is this cannot be 3, 4, or 5. Sorry, 3 or 4. Because if this is 3 or 4, this is at least 4 and 3 adding up to 7. 3 and 4 and 2 at minimum, at maximum add up to 6, which is obviously too small. Can we have 3 digits here or 3 digits here? I think the answer is no. If we have 3 digits here, this is 3, 4, and 5 adding up to 12, which 9 and 2 never can add up to. Same with this. This is 3, 4, and 5. Well, it can't even be 3, 4. It'd be 3, 6, and 5 here, which is too big. So this cannot be on the path, which means this can never have 5 in the surrounding area that the rat goes through. So this is 3 or 4. That means this is 3 or 4. This is 3 or 4, which means we cannot have 3 or 4 in the rest of the row. Okay, that's interesting. That means we're guaranteed 4 has to be one of these 2 digits here, which means this cannot be 4 and 5 to add up to the same sum. So no 5 or 9 there. This could be 6. Can this ever be 9? 9 and 4 adds up to 13, which does not equal to the same sum as that. So this cannot be 9. So this adds up to either 4, 5, which adds up to 9 at minimum. So this adds up to 9 at minimum. So this has to be at least 7 here. 7, 8, or 9. We have a guaranteed 3 in one of these 2 cells. So that eliminates 3 in the rest of the box. So this cannot be 3 and 6. So no 6 there. Okay. This is a singleton digit, which must be the sum of 3 unique digits, including a 4. So this has to be 7, 8, or 9 here, to be summing up to whatever these digits are here. So this has to be, it can be at most 1 through 3 here. Interesting. Huh. So where is 6 in row 6? It has to be one of these 3 digits here, which eliminates 6 in the rest of the box. So this cannot be 6 there. That means we have to have a 6 somewhere here. This can be 2, 4, 6, 7, 8, 9. Okay. If this were 7, that would force this to be a 4, which would be in a 1-2 ratio with 8, but that would eliminate all possibilities for this pair of digits adding up to the 9 here. Because we can't have 3, we can't have 4, we can't have 7 and 8 then, that eliminates all possibilities. So this cannot be 7, this has to be a 5. That eliminates 5 in the rest of the row. Okay. Hmm. If this were 8, that would force this to be 2, and this would add up to at most 12 or 11. And 8 and 5 was already 13, so this cannot be 8 here. Interesting. Same with this. If this is 8, then you'd have 2 guaranteed to be there. 2 and 9 add up to at most 11. 5 and 8 already add up to too much. So this cannot be 1 here. If this is 7, well, that's fine. If this is 2, I guess it, oh. Remaining digits here cannot be 6 or 8. So we have 1, 3, 4, 5, no 4 because we are guaranteed 4 is one of these digits. 1, 3, now we could have 2 also. 1, 2, 3, no 4, no 5, no 6. It could be 7 or 9 there. Okay. This cannot be 1. If this is 1, this is 8. That adds up to 9, which how does that add? So 9, how does this add up to 9? It can't be 4, 5, 1. It can't be 2, 5, 1, and 1. That's not going to work. So this can't be 1 here in general. It would have to be 2 and 4 at least with 5. 2 and 8 could work with 4, 5, 1. That is potentially possible. But if this is 2, so if this is 2, this is 8. That would have to force this to be 4, 5, 1, but that would force this to be 8, which would mean 8 is there, and that would be a contradiction because we have 2 8s in the same row. So this can't be 2 either. Interesting. Can this be 2 is kind of a question. If this is 2, this is 7 or 8. Well, if we have 2 here, this can't be 2. You can't have 2 and 7 here. Okay, can we have 3 and 8 here is kind of a question too. 3 and 8 adds up to 11. So we could have 2, 4, and 5 there, and that could work. We have a 3 guaranteed here, which means we must have 3 guaranteed here. This is 5. So this is either 4, 5 or 6, 5 here. That adds up to 9 or 11. So this could be 2, 7, 1, 8, or it's 2, 9 here. Okay. This can never be 8. If this is 8, that would force this to be 1 and 3, which would eliminate 3 and 8 as possibilities here, which obviously doesn't work. So this can never be 8. Therefore, we are guaranteed one of these is a 2. Whoops. One of these is a 2. These two digits must sum up to that digit. That doesn't tell us very much. This cannot be 2. If this is 2, 4, 2, and 9 at most, which adds up to 15, would force this to be a 7-8 pair, which adds up to 15, plus another digit, which is obviously not going to work. So this cannot be 2. This is guaranteed to be 8. That's interesting. That means this cannot be 8. This cannot be 8. This is 7, 9 as a pair. That adds up to 16, which is 6, 5, 2, and 3 here. So we have 2 here. This is 1. That means we cannot have 2 or 9 here. We are guaranteed a 1 here. This is 2. To add up to 9 is 2 and 7. To add up to 11, it's 2 and 9. Okay, this is 3. This is 8. 8 and 3 can be 4, 5, and 2. This is 1, 2, 5, 6, 7, or 9. Also 1, 2, 5, 6, 7, or 9. Can this be 9? I think the answer to that is no. That would force us to be 7 and 2. So 9, 8, and 4 is 21. 7 and 2 is only 9. 21 minus 9, which means that digit would be 12, obviously, which doesn't work. So no 9 there. Eight and 9. It would have to be 4 digits here then. Can we have all 4 digits here? So these two plus these two. And the answer is no. 3 and 6 only adds up to 9, which 4 unique digits can never add up to. And 3 and 8... Oh, I guess this could be green, though, also. Forgot about that. Right. So this cannot be 8. Therefore, this is 2, 7 as a pair. Oh, okay. That eliminates 2 and 7 in the rest of the column, or row. Interesting. Remaining digits in this box are 1, no 2, no 3, 4, no 5, 6, no 7, 8, or 9. So 8 can't be here because of 8 in the column. 4 can't be here because of 4 in the column. We have to have 1 digit here. We don't have really any information here. Remaining digits in row 9 could be 1, 3, 4, 5, 6, 8. Obviously no 9 here because of 9 in the row. No 4s here because one of these 2 digits is a 4 here. No 4 here because one of these 2 is 4 to be in a 1-to-2 ratio. Yeah, the logic behind this isn't that hard. It's just that you have to go through a lot of calculations here. If this is 2, 7, and 9, that adds up to 18, which would force that to be 6. So that does work. Can we ever have a 1 here? 1, 2, and 9 obviously is too small because that's already 12, which 4 and 8 already add up to. 1, 7, and 9 adds up to 17, which would have to force 5 to be there. So that could work. So let's look at all the possibilities. We have what? 2, 7, 9. That adds up to 18, which would force that to be 6. We have 1 here. And it could be with 1, 7, 9. That adds up to 17. So then 5, 4, and 8 adds up to 17. How about 5? 5, 2, 7 adds up to 14. But that would require 2 to be there. So that doesn't work. 5, 9, and 7 is too large, I think. 21. Let's do the remaining digits actually in column 8. We have 2, 5, 6, or 7. So that's interesting too. Where is 1? 1 in row 3 has... Well, that's not true necessarily. Can we have 1 here? 1, 4, and 8 is 13. 2 and 7 is 9. 14 plus 9 would be 5? No, it's 13. It would have to be 2, 7, and 4, which obviously doesn't work. And you can't have 7, 9, or 2 and 9. 2, 9, and 2. So this cannot be 1 here. Can we have 2 here? No, that would be 7 and 9 here. So 1 is going to have to be one of these 2 digits here, which means this can't be 1 here. Because we can't have 1 here. We can't have 2 here. 2, 4, and 8 forces, that adds up to only 14. 7 and 9 already by themselves add up to... Oh, this can't be 2 or 7 because... No, that's not true. Never mind. Could be 5 and 6 here. Could be 7 or 9 here, potentially. 9, I don't think so. 9 would make this guaranteed to be 2 and 7. 9, 8, 4 add up to 21. 2 and 7 add up to 9. 21 minus 9 is 12, so no. 7, I think, also doesn't work. If you have 7 here, that's 2 and 9 here guaranteed. So 7 plus 8 plus 4 is 19. 2 and 9 is 11. 19 minus 11 is 8, which would force 8 to be here, but we have an 8 in the row. So this is only 5 or 6 here, interestingly enough. Can we have a 5 or 6 here, then? Probably not. If we have 5 here, that would force this to be 6, 8, 4, which is 18. 18 minus 5 would be 13. We don't have 4, 9 available. We don't have 5, 8 available. We don't have 6, 7 available in that instance. So this cannot be 5. Can this be 6? If this is 6, we have 4, 8, and 5 adding up to 17. 17. Oh, that could work. So you could have 2 and 9 here with the 6 there. So 6 does work there. Ugh, okay. Well. If this is 7, what does that mean? If this is 7, that means this is 7. This becomes 6. Therefore, this would be 2, this would be 4. And you'd have these 4 digits adding up with these 2, which does work with 2 and 7. So that actually does work. Never mind. So 6 could be there. Ugh. This is fairly complex. This is odd. That's odd. That's odd. Uh, Remaining digits of column 7 are 4 through 9. So this is the very hard part of this puzzle. It's just trying to figure out how the sum up, right? um uh, hmm. This is pretty complex. Obviously this is 1, 2, 5, 6, 7, 9 as possibilities. Can this be 5 anymore? 4, 5, and 9 add up to 18. And 2 digits never add up to that. 4, 5, and 7 adds up to 16, which would force this to be 7, 9 as a pair, which would eliminate all possibilities for that cell. So this cannot be 5 here. Can this be 3 now? If this is 3, that makes this 1. I guess 3 and 9 with 1, 4, and 7 does work. Ugh, this is convoluted. My brain is starting to hurt a little bit from this. Hmm. 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 This can't be a singleton. If this were a singleton, it would be 7 at most. And then this is adding up to 5 and 3 at least. So we have to go that way. We don't really, I mean, this doesn't really have to go in any order, right? Unless it doesn't go there. which is also possible. Could have 7 and 1, adding up to 3 and 5. Hmm. Kind of convoluted. Well, either way, if we do include this, I mean, she can go any which way there. It's likely then that she goes this way, then that way, right? Because otherwise it doesn't make any sense. Like, if this were included, she could go this way, she could go this way, she could go, um, yeah, those are the, she could go this way. So that's why I'm thinking that this is unlike, ugh, come on. And then we enter from there. Because that makes me suspect that this is not part of it. Because if it is, then she could go any of these patterns. She could go 1, 2, 3, 4. She could go 1, 2, 3, 4. She could go 1, 2, 3, 4. And those are the 3 patterns she could be. And then this would be ambiguous, but maybe that's fine. I don't know. Hmm. Interesting. Can we have 9 here? 9 and 2, 5 and 6 works. Ugh. 8 and 9 is interesting. Okay, what happens if this is 8 and 9? If we have 8 and 9, that makes this 7, that's 9, that's 7. So this can't be 7 there, that would be 2. Which would make that 7. That seems to work okay. 17, then this would be 4 and 1. Hmm. Oh, this is okay, that's problematic. Yeah, this is 15. This is 15. And we have 1 digit here and 3 digits here. And 3 digits trying to add up to a singleton digit, which cannot be 6, 7, or 8, or 9, is not going to work. So that's a contradiction there. So this cannot be 9 here. What about if this is 7? Maybe that does. It's fine. That's 7, which makes this 9, which makes this not 9. It's 7, that's 9 there. That means this can't be 7. This is 9. That means this has to be a 2-3 pair here. So that's okay so far. This is 15. 4, 5, and 7 doesn't work. 4, 5, and 2 doesn't work. You have to include that. Oh, whoops. I forgot. That's not 9. Let's include these lines. Let's try it again. So try this as 7. That's 9 there. This is 9. This becomes a 2-3 pair. That means this can't be 2 or 3. That's interesting. So this is 9. This cannot be 2 or 3. It has to be 8. That means this is 4. So this must be 2 and 7. Okay. That seems okay-ish. No 9 here. 7 and 9. No 7 here. This is 15. That means these 3 digits must add up to 10, which is 15 minus 5. So it would have to be 2. That would be 4. This would be 1. That would be 7, and that's 2. Okay. 2 and 9, which means this would not be 2. This would not add up to what these are, because this is 1, 3, 5, 9 plus 6, which is 15. So we would have to include this. No 2 or 9. Therefore, this would have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this motion sensor would be 7. And that does work. So that would be, what, 8 here? No, 6 here. So 2, 9, 6 here, which adds up to 17. And then 8 plus 1, 3, 5, which adds up to 17. This 2 eliminates 2 here, so that's 3. 3, 7, 6 adds up to 16. This adds up to 17. So no 3, 7, or 9 here. 4 eliminates 4 here. So this actually does kind of work. Dang it. No 3 here. No 7 here. No 9 here. This has to be 2 and 9 here. But we don't have 4 available in this box. And that's a contradiction. Okay. Well, there we go. So this cannot be 8 and 7. That means this has to be 8 and 3. So there's no 3 here. This then must add up to 11. So, and it can only add up to 11 if this is 2 and that's 4. So this is not part of the path. So we do have to go that way, so that my intuition was correct. Therefore, this is 4, 5, and 2 to add up to the same sum. 2 eliminates 2 here, so that's 7. That's the same digit as that, so 7 eliminates 7 here, so it's 9 and 7, which means this can't be 7. That's 9. 9 eliminates 7 and 9 here. This is 16. So this must be 1 or 2 here. 7 and no 7, 9 here. No 7 here. This is 7, which means this can't be 7. It's 6. So this cannot be part of the path, which means we must go that way. 6 eliminates 6 here. So this is 2 or 8. We can't have, if this were 8, that would force this to add up to 17, and 4 and 9 cannot add up to 17, or 4 and 7 cannot add up to 17. So this must be 2. That's 2, 1, 3, 5. That adds up to 11. So this must be 4 and 7. No 4 or 2 here, so that's 8. That leaves this as 9. 2 eliminates 2 here, so that's 1. So no 1 here. 1, 7, 9 adds up to 17. 17 minus 4 and 8 is a 5. So that's 5 there. This is 7. That eliminates 7 in the rest of the box. 3 eliminates 3 in the rest of the box. 5 eliminates 5 in the rest of the column. This cannot be 7 and 1 then. This adds up to 7 here, so this is 1 and 2 with 4. So that means this cannot be 1 here. This can't be 1. Where is the 1 in box 7? It has to be here. So that's 1 there. Because again, 1 and 7 can never add up to 5 and 6. So these are possibilities are 5 and 6. Okay, 7 eliminates 7 here. 1 eliminates 1 here, so that's 3. 3, 4, and 7 add up to 14, which is 5 and 9, or 6 and 8. So you could have 5 and 9, or this is 8 and 6 there. So 5 and you cannot have 5 and 9 here, but that adds up to 14, which 7 and 7 would have to be. So this must be 5 and 6. So that makes that 8. That leaves this as 4 and 7 to add up to 11. This can't be 4 then. It's 3, which makes this 8. That makes this 8 and 4 in a 1 to 2 ratio. That leaves this as 7 and 2 to add up to 9. This cannot be 7 or 8. It's 6. This can't be 6. It's 8. 8 eliminates 8 here, so it's 4. This can't be 4, 6, or 8. It's 5, which leaves that as 7. This can't be 6, 7, or 8. It's 9. No 6, 7, 8, 9 here. No 6, 8 here. No more 5s here. 8 eliminates 8 here, so it's 6. This can't be 6 or 8. It's 9. That means this cannot be 6 here. Remaining digits in row 8 are 2, 5, and 6. 6 cannot be here because of 6 in the column. 5 eliminates 5 in the rest of the row here. No more 7 here. This can't be 5, 6, 8, or 9. It's 4, 7 as a pair. 4 eliminates 4 here. So this becomes a 1, 8 pair. Okay. 9 eliminates 9 here, so that's a 1. That means this can't be 1, that's 2. This can't be 2, that's 1. This adds up to 3, 4, 5. So it must be 2, 3, or 4 here to add up with the 1 to add up to 3, 4, 5. 1, 2, 3 eliminates 1, 2, 3 here. It's 4, 5. This is 3 digits, which have to add up to these 2 here. So this cannot be on this column because then it doesn't add up. So this must be 5. That means this can't be 5 here. This is 11, so this must add up to 11, which is a 2, 5 pair, which eliminates 2 and 5 in the rest of the row, so this can't be 2, it's 6. This can't be 1 or 3 because of 1, 3 in the column, so that's 8. No 8 here. 4, this has to be a 4, 7 pair. 4 eliminates 4 here, so that's 7 and 4. Remaining digit in box 5 is a 1. That eliminates 1 here, so it's 3 and 1 there. 4 eliminates 4 here, so this cannot be 1 and 3 adding up to 4. This can't be 4 here because of 4 in the column, so this is 1 and 2 adding up to 3 here. 2 eliminates 2 here, so this is 6, which makes that 2. 2 eliminates 2 here, so it's 5 and 2. We have 5, 9 remaining here in row 4. This can't be 5 because of 5 in the column, so that's 9 and 5. The rest, I think, is just normal Sudoku. Let's make sure that these sums add up. Row 2, 1 and 2 add up to 3. Row 3, 4, 5, and 8 add up to 17. 1, 7, and 9 add up to 17. Row 4, 6 and 8 add up to 14. 3, 4, and 7 add up to 14. Row 5, 2, 3, 4, 7, 6. So that's 9 plus 7 and 6, which is 22. 5, 9, and 8 add up to 22. Row 6, 4 and 7 add up to 11. 1, 2, 3, 5 add up to 11. Row 7, 5 and 4 add up to 9. 7 and 2 add up to 9. Row 8, 4, 2, 5 add up to 11. 8 and 3 add up to 11. Row 9, 7 and 2 add up to 9. 9 adds up to 9. Column 1, 5, 6 adds up to 11. 4, 7 adds up to 11. Column 2, 3, 8 adds up to 11. 4, 5, and 2 add up to 11. Column 3, 1, 2, 4 add up to 7. 7 adds up to 7. Column 4, 2 and 7 add up to 9. 4 and 5 add up to 9. Column 5, 2, 3, 7 adds up to 12. 4 and 8 adds up to 12. Column 6, 1, 3, 5 adds up to 9. 2 and 7 adds up to 9. Column 7, 1 and 8 add up to 9. 9 adds up to 9. Column 8, 3 and 9 add up to 12. 4 and 8 add up to 12. Column 9, 7, 9 add up to 16. 2, 6, 3, and 5 add up to 16 also. So yes, this is just normal Sudoku from now on because we have everything solved. Column 1, we have 2 and 9 remaining. 2 can't be here because of 2 in the column. So this is not, or 2 in the row, so this is 9, that's 2 there. Also, 1 eliminates 1 here, so it's 8 and 1. Column 3, we are left with a 3. Column 2, we are left with 6 and 7. Okay, column 4, we are left with a 8. Column 5, we are left with a 5. That eliminates 5 here, so it's 6 and 5 here. 6 eliminates 6 here, so it's 7 and 6 here. 7 eliminates 7 here, so it's 4 and 7. That leaves this as a 9, and this as a 4. Experiment completed successfully. Date, March 25th, 1975. Cells visited, 40. Black currants eaten, 2. Red currants eaten, 2. Elliot actually joined me for today's test. We spoke briefly about the baby. I mentioned that they've decided on the name Zoe, and she's expected around the beginning of June. He considered this for a moment, nodded, and said, Zoe was a strong choice, short and efficient, before promptly turning back to observing F and P. For a moment, I thought he might say more, but the conversation drifted away as quickly as it had begun. Everything seems to these days. Yeah, this was just, a lot of calculation. There was some, this was a fun part. Like, the rat run puzzles are always pretty fun. So, but this was a lot of just math involved, I felt. But the logic wasn't hard. It was just basically, figuring out where things could be and then adding up things and seeing what happens when you add things together. So, yeah. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.